Hello and good day to you all. I'd like to thank you for taking the time and to listening to about the Earth Sciences Department here at Stellenbosch University. But first, my name is Dr. Ryan Tucker. I am the sedimentologist and paleontologist within the department. But first, before we get into the nitty-gritty about the department and what you should expect as an incoming student learner, I'd like to bring your attention to this quote from the cult classic Shawshank Redemption. Now, I won't read through this, but what we should pay attention and draw from this is Morgan Freeman's approach to understanding the removal of time while you're sitting in prison. And this is very applicable to geological processes. Because even though we look at day-to-day events currently happening around us, geology is very focused on what has happened in Earth's history. And so we may look at 1,000-year increments, million-year increments, or billion-year increments. And so what we find is that irrespective of this time, we can reduce the changes that Earth has undergone in the last 4.6 billion years, is that it comes down to pressure and time. How much pressure does it take to move a continent, to build a mountain, or to erupt a volcano? Furthermore, what is the relevance of this science? Ever increasingly, we find that humans have had an impact on the Earth, whether it's historically, actively, or in the future. And to prolong our existence on this Earth, we need to find better ways of working with the Earth to prolong not only our existence, but the ecosystems in which we live and the global sphere as a whole. And so Earth Sciences is readily trying to tackle these questions of how can we be effective at generating energy while simultaneously perfecting it so that it does not cause detrimental effects to the ecosystems around us. And furthermore, how can we actually make a product such as a cell phone or a laptop that you're actually watching this video on in a way that is environmentally sound and actually not only sound but protects the environments in which we are obtaining these key minerals for the products that you use every day. And so the relevance of the science is ever increasing as we try to tackle these major disruptions into our climate now and into the future. But first of all, the important thing, finding a job. So as a high school student and entering the university field, this is kind of this big esoteric idea of what is a job, what kind of jobs can I have, and geology, what is there actually out there. So within our department, we are split between what we call applied, which is dealing more with the rock itself, and environmental, so looking at climate change. So first of all, within applied, we do have mining. We do actively engage with economic corporations both in sub-Saharan Africa, around the world, looking at the extraction of various minerals, be it palladium, gold, diamonds, for economic or interest there. But we also do consultancy. You know, how can a mine open? What are the effects to the landscape if it does open? And maybe actually saying that no, you can't open because this area is sensitive to maybe slumpage or ecosystemally it should not be done. We can work with engineers for bridges, roads, actually building tunnels, looking at the competency of rock and if we can actually build these structures. You can get into exploratory geology, you know, kind of exploring the outermost reaches of the Earth's surface and looking at that very poorly contextualized topography and understanding the geology of the area. So areas such as Antarctica, Mongolia, Siberia of Russia, these very poorly contexted landscapes. To even academics, you know, trying to educate the future generation of geoscientists and further the forefront of cutting-edge science. This is mirrored within our environmental stream. Jobs that can be undertaken go from waste management and dealing with land reclamation after a mining event has taken place. Governments taking an active role in legislation for the protection and hopeful development of ecosystems that are prolonged rather than destroyed. You can work with agriculture. So the big thing around Stellenbosch University, of course, is the winelands. So actually dealing with the soils themselves and how they affect not only the fruitfulness of the vines, but also the taste of the wine itself. And this can even be with forensics. Crime scenes happen outdoors. It may be dependent on sediments that interacted somehow with that event, and so they can call on environmental geoscientists to help elucidate and try to capture the guilty party. Now, this takes us to what students are typical within our department, and what we find is this is ever increasingly diversified. We have a very keen interest in nature and its inner workings. However, that is very broadly encompassing. And so we've got students that absolutely love to be outdoors. They want to be in the mountains. They want to be in the veldt exploring what is potentially the development of that landscape and that ecosystem. Whereas we've also got students that are very tech savvy, and so they're actually looking at cutting edge and novel ways to assess that rock in an analytical setting. So in a lab, looking at the chemistry, looking at the physicality of that rock in a more kind of systematic approach in a lab setting. And so both of those we find students take active roles in. But really, we're not that, old idea of this is a kind of a limited field. We are ever diversifying, and bringing in those different skill sets is actually allowing earth sciences to be much more productive. In terms of our staff profile, we are global. Most of our staff actually come from outside South Africa, and this is reflected within their skill sets ranging from geochemistry, tectonics, we got hydrology, metamorphic, igneous, and of course sedimentary as myself. Most of our staff are rated by the NRF. Most of them hold active research grants through the National Research Foundation in South Africa or internationally through, let's say, the National Science Foundation in the US and similar bodies in Europe and Asia. The projects that we actually take on are again, global. Projects range on every single continent on Earth, including Antarctica. This ranges from Southern Ocean profiles to fossil assemblages in Brazil and Mongolia, to actually looking at emplacement history of gold within the Vits within South Africa. And so our staff actively engage in global projects, and we also actually attract students within our department to take leading roles within these projects. And so early on in your academic career, you can take leading roles within these ever-diversifying projects around the world. Now, to complement this field portfolio, we have an active research in-house at Stellenbosch University. With collaborations with SAF, or Stellenbosch Central Analytical Facility, we can age date rock. And so for my own expertise, I can take minerals that are found next to the fossil and give that fossil an age date, whether it be 100 million years or several hundred million years. Vice versa, in terms of our environmental stream, you can take active roles within geotraces. And so looking at various isotopes that are found within the Southern Ocean and how that is affecting those biospheres and Antarctica and ocean currents itself. This research is in collaboration with multiple partners around the world, and even domestic ones. So as Eco Museum, we've got various collaborations with University of Cape Town, and two global partners, so looking at the Field Museum in Chicago, Illinois, or James Cook University in Australia. And students are readily brought on board to take leading roles within these networks to grow not only that collaboration network around the world, but also their own scientific skill set within the geosciences. But to actually get to the nitty-gritty, first of all, you need a BSc. This is a 3-year program. We have 2 streams. This is split between applied, which is more rock-based, and we have the geo-environmental. Both of these have selective courses that are specific for that field, and then you have a mix of elective courses in various topics that you're allowed to take within that. To give you a little bit better idea about this, we find that in first year is the foundation year. We give you your basics, including just an introductory to geology and what it means to be within geoscientists. We have a field skills course that starts to get you into the basic concepts of what it means to be a field geologist and analytically in the lab as well. Second year, we start to specialize. You'll take courses such as geochemistry, mineralogy, structure, and these are to get your mindsets into the key essentials of what we look at in terms of processes within Earth's history. And then our third year is our capstone courses. This is where you start to specialize in certain facets within geology, ranging from igneous, hydrology, economic, and sedimentary geology. This is all complemented by our multi-year field program, where students are actively taking leading roles within specific fields. So you'll be testing water in Table Bay or False Bay. You'll be mapping based on topography in Lanesburg in the famed Karoo. Or you could be actually looking at metamorphic events along the coastal platform of South Africa. So all of these field excursions range from a day to maybe a couple weeks, but they actively engage you. You are able to put your finger on the study at hand and understand the topic. In terms of our postgraduate, we start off with an honor. This is a full-year program in which students choose to be in applied geology or environmental geochemistry. This is complemented with a suite of classes that are recommended for that field, along with electives. Alongside this, we have a thesis. The thesis is a collaboration between you as the honor student and an advisor with a specialized project within a certain field, say igneous, metamorphic, tectonics, and or sedimentary geology. You will research that question, you will go out into the field and recover data, and then you answer a question based on your findings. Continuing forward, we have both a MSc and PhD program. These are award-winning and globally networked. Most of our MSc and PhD projects are sub-Saharan, either economically and or chemically. We also look towards the Southern Ocean, looking at trace metals, to maybe PhD work in Mongolia or North America, looking at fossil assemblages and how sediments interacted with their preservation. So we start this off with the approval of a project proposal and improvement of your committee, and then you actually do the work over 2 years for an MSc or 3 years for a PhD, and then at the end you actually defend that work against a committee. Again, these projects are ever expanding and ever diversified, and they're very entrained into a global platform in which your results are put out there into a network of meaningful science. And so what you actually are able to produce will actually benefit science and a global understanding of what's going on. And last but not least, we have our outreach. Here is very vital that we interact with key partners within the Western Cape. And so this is to allow student learners from a primary or secondary level to take active roles within science. Some of this is just bringing them into our department and then showing them what it means to actually be a geoscientist, looking at rocks, looking at water testing, and what we actually do day to day. Or we have online citizen science or STEM-based projects in which student learners take active role in data collection. Now, this data is not just esoteric, it's not floating around. This will be actually published data by scientists around the world. And so integrating these student learners into real science, and our students, in terms of undergraduate or postgraduates, take this as real-time outreach. So thank you very much for your attention, Donkey and Kose, and have a wonderful day further.